Hi, my name is Elaine Tintoni, and I'm the lead online math instructor at ICC, and I'm going to be taking you through this online statistics course. We'll be using the book Fundamentals of Statistics, 5th edition by Michael Sullivan. It's actually based on the book that you see here. It's a subset, mostly, of this book, and it's published by Pearson. We're going to start in section 1.1, and what we're going to be talking about in this section is the definition of statistics and what it means to think statistically, the process of statistics, and then we're going to talk about some variables. We're going to talk about qualitative versus quantitative variables, also discrete versus continuous variables, and then we'll talk about the level of measurement of a variable. Now, before we get started, if you're taking this class online through ICC, I hope you've already gotten into Canvas and printed out the notes that go with this section. Every section that we cover will have an Adobe Acrobat Reader file of notes that you can download and print, and you can fill those out as we go through the videos together. And what that will do is that will give you something tangible to study when it comes time to study for quizzes or proctor tests. And it also makes it easier for you to take down the information because all of the definitions, all of the terms will already be there for you, and you'll just have to fill in key things, and you won't have to draw any diagrams. It'll all go right along with the textbook. So here we go. The very first thing we need to do is get a definition for statistics. So the definition of statistics is, this is the science of collecting, organizing, summarizing, and analyzing information to draw conclusions or answer questions. In addition, statistics is about providing a measure of confidence in any conclusions. So there's a lot going on here. So let's kind of break it down. We have 4 parts. First of all, statistics involves the collection of data. And then after you collect the data, it involves the organizing and summarizing of the information. And then the information is analyzed to draw conclusions, and the results are reported using some measure of confidence. So we will spend some time on each one of these parts. Chapter 1 is pretty much all about the collection of data. So actually, while we're going through Chapter 1, this won't even feel like a math course at all. But Chapter 1 is the collection of data. In Chapters 2 and 3, and part of Chapter 4, we'll look at organizing and summarizing data. And then the rest of the course is pretty much devoted to analyzing, drawing conclusions, and attaching a measure of confidence to our conclusions. Now, the information referred to in the definition is data. Data is defined as a fact or proposition used to draw a conclusion or make a decision. Data describe the characteristics of an individual. And therefore, a key aspect of data is that they vary. So one piece of data about you is your hair color, and your hair color is not the same as everybody else's. And another piece of data about you is your eye color. And another piece of data about you is your height. And another piece of data about you is your address. So data can vary from person to person, and that's why we're interested in measuring them. If they were all the same, well, we wouldn't need to measure the data at all. Now, data can be quantitative, such as weight and height and age, or it can be qualitative, such as the title of a book or a state of residence or the medications that have been prescribed to a patient. So you see the word quantity in the word quantitative, so that tells you that we're talking about something numerical. Height, weight, and age are all things that are expressed in numbers. And then do you see the word quality in the word qualitative? And so qualitative data describes some quality of the individual. So if we're talking about a book, we could talk about its title. If we're talking about a person, we could talk about the state where they live or the medicines that they take. And those would be qualitative pieces of data. Now, before we go really any further, I want to make sure that you understand why statistics is worth studying anyway. What statistics does for us is it helps us draw conclusions using data. For example, suppose you know 3 people who drink a lot of coffee and those 3 people frequently catch colds. Would that prove to you that drinking coffee causes colds? Well, probably not, because 3 people is not a lot, and it may just be a coincidence that you know those 3 people who drink a lot of coffee and also catch a lot of colds. But what if you had 1,000 people who drink a lot of coffee and catch a lot of colds? Would that change your mind? Would you start to feel like there's a link between coffee and colds, or would that not be enough people to make a decision? This is the kind of thing that statistics helps us to sort out. So, analysis of data, which is the science of statistics, can help us refute anecdotal claims. Now, here's another application of statistics that I think all of us have had some contact with in the last year or so. If we want to make a reasonable prediction about who is going to win the next election, do we have to contact every voter? Did you ever wonder how they decide how many people it's necessary to talk to before they can make a prediction about how the campaigns are going? Do they try to talk to as many voters as possible? Is there some method to the way they choose those voters? Every voter that they talk to, every voter that a pollster talks to, it takes time and money. It takes time to ask them the questions, to find the people and ask them the questions. And it takes money because you have to pay a pollster to do that, and you have to analyze the data. And so how can we do that cheaply and quickly? You know, if you're a pollster or if you're a candidate and your campaign is running polls to see how you're doing, you're interested in getting valid information as quickly and cheaply as you can. So statistics helps us know how many people do we need to talk to get this information, and how do we choose those people to be able to draw some conclusion about the whole population. So one use of statistics is to help us use data from a sample to draw conclusions about a population. Here's another thing to think about. How many third graders would we have to weigh to find out what the average third grader weighs? You know, you see things like this thrown around in news stories all the time. They talk about the average weight of children. They talk about the average income of men, or the average income of women, or the average life expectancy of a certain group of people. So how do they know? Do they have to measure all of the individuals in that group? And if we can get away with just measuring a sample, a few of the people from that group, then wouldn't any 2 samples be different? Won't each sample of third graders be different? How can we be confident that a particular sample represents the population that it came from? So these are all things that statistics can help us with. In other words, different samples will yield different results, and the science of statistics helps us determine how confident we are that our results are correct. Now let's nail down a little terminology. I've been throwing around the words population and sample, so let's get definitions for those. The entire group to be studied is called the population. So the population includes everyone whose characteristics are of interest to you at the moment. And then a sample is a subset of the population being studied. So the population is everyone you're interested in, and a sample is a smaller group of people that come from the population. And then an individual is a person or object that is a member of the population being studied. So here we have a population. From that population comes the sample, and then an individual is just one person from the population. Now a few more definitions. First of all, we have really 2 branches of statistics. We have descriptive statistics, and we also have inferential statistics. Descriptive statistics consists of organizing and summarizing data. Descriptive statistics describe data through numerical summaries, tables, and graphs. Okay, so this branch of statistics that's called descriptive statistics means we are only describing a data set. Okay, now a numerical summary of a sample is called a statistic. A statistic is a numerical summary based on a sample. So a numerical summary means a mean or a median or a range or a mode or a standard deviation. Any number you've calculated to describe a sample is a statistic. Okay, now the other branch of statistics is called inferential statistics. The difference is with descriptive statistics, you are only describing a sample or describing a population. With inferential statistics, you're taking information about a sample and using it to draw a conclusion about a population. So inferential statistics uses methods that take results from a sample and extends them to the population and measures the reliability of the result. And don't forget that part, that's very important. So, for example, let's say that I have 200 college algebra students and I've just given a test and I want to know the average test grade. Well, if I randomly choose 10 out of the 200 and I average those, I now have a statistic because I am calculating a numerical summary based on a sample. Remember, 10 out of 200. If I then take that mean of 10 test grades and I say I only averaged 10 of these and say the average was 83, okay? And now I'm going to say that based on those 10 papers, I believe that the average of all 200 is probably somewhere between 80 and 86. That is inferential statistics because what I've done is I've taken information about a sample and I have extended that to the population. I've used information about a sample to draw some conclusion about the larger population that I have not truly studied. And I also would need to include some kind of reliability of result. In other words, I would need to say I'm 90% sure that the average of the whole 200 papers is between 80 and 86. So do you see the difference between descriptive and inferential? Descriptive just says, here's a number that describes this group. And inferential says, based on information about this sample, I believe something to be true about the population, and I am X% sure that it's true. So that's inferential means we are inferring something that we didn't directly calculate. We also have one more definition on this slide, and that is parameter. Now, a parameter is just a numerical summary of a population. Okay, so we have two words here, depending on whether our numbers came from a sample or a population. If we have numbers from a sample, a numerical summary of those numbers is called a statistic. But if we have numbers from a population, a numerical summary of a population is called a parameter. Okay, if you'll just keep the letters lined up, you'll be fine. S for sample, S for statistic, P for population, P for parameter. So a parameter is a numerical summary of a population. And often, keep in mind that very often it's impossible to calculate this number because populations get so large, it becomes impossible to directly measure every single individual in the population. And therefore, you cannot usually calculate a mean of a population. Usually, what we have to do is get a mean of a sample and use inferential statistics to make our best guess at the parameter. That's really the root of what we're trying to get at in this course. And we won't get there until the very, very end of the course. But the question throughout the semester is, How can I take something I know about a statistic and extend it to where I can say something about the population? Because usually it's not the sample itself we're interested in. We're interested in making some kind of educated guess at some characteristic of a population. We're almost always trying to estimate a parameter. Now, the thing about inferential statistics is that there's always going to be some level of uncertainty because a sample can't tell us everything about a population. And if you think about it, that just makes sense. Say you had 100 people and you asked them all how much money they have in their pockets. Well, if we take any group of 10 out of that 100, the average for the small group of 10 is going to be different from group to group, but it's also going to be a little different from the small group to the larger group, which is the population. So just using a sample introduces some uncertainty. And in inferential statistics, we always have to be careful to state the level of confidence in the results. Therefore, inferential statistics always includes a level of confidence in the results. And as we said earlier, one goal of inferential statistics is to use statistics from a sample to estimate the parameters of a population. So that's the big picture here. We want to be able to use easy to get information from a sample to estimate a parameter that would be very difficult to calculate directly. Okay, so one more time. A statistic is information about a sample, and a parameter is information about a population. And one of our goals in statistics is to use information about a sample to draw a conclusion about a population. Okay, now with that in mind, let's look at a couple of situations and see if we can decide if we're looking at a parameter or a statistic. So this is example 1. It says, suppose the percentage of all students on your campus who have a job is 84.9%. Is this a parameter or a statistic? Well, it depends on really who you're interested in. So it just says all students on your campus. So I'm assuming that the group we're interested in is the students on campus, and we have a number that describes all of them. So I'm going to say this is a parameter because it is a numerical summary of a population, the population being the students on campus. Now suppose we have a sample of 250 students, and from this sample we find that 86.4% have a job. 86.4% of the 250, which is not everybody on campus. Is this a parameter or a statistic? This is a statistic because it comes from a sample, and that's it. So a parameter is a numerical summary of a population, and a statistic is a numerical summary of a sample. Okay, now let's talk about the process of statistics. And this is kind of the general process that a researcher will go through when they're trying to draw some conclusion about a population based on a sample. So first of all, we have to identify the research objective. In other words, a researcher must determine the question that he or she wants answered, and the question must clearly identify the population that is to be studied. After you identify the research objective, then you need to collect the data needed to answer the question. Usually conducting research on an entire population is difficult and expensive, so we usually look at a sample. And this is a vital step in the statistical process because if the data are not collected correctly, the conclusions drawn are meaningless. Do not overlook the importance of appropriate data collection. So we're going to talk in the rest of this chapter about a few different sampling methods, and really my goal is not to make you into a researcher. This is just an introductory course. My goal is just really to help you understand what a researcher does so that when you read a study as maybe a medical professional or a social work professional, you understand whether the method used is basically flawed or basically valid. So these are just things we need to think about. After we collect the data, the next thing to do is describe the data. Descriptive statistics allow the researcher to obtain an overview of the data and can help determine the type of statistical methods the researcher should use. And this is the focus of chapters 2 through 4. So should we use a mean or a median? Does the mode help us at all or not? If we want to talk about how far the data are spread out, should we talk about the range of the data or the variance or the standard deviation? So all of those things are numerical summaries of our sample. So all of those things are statistics, but which ones are the best ones to use to describe our data? That's what we have to think about in this step. And then after we get our statistics, then we want to perform inference. In other words, we want to take our statistics and see what that tells us about the larger population. So we want to apply the appropriate techniques to extend the results obtained from the sample to the population and report a level of reliability, or in other words, a level of confidence. And this is basically the focus of the second half of the course. And people spend years studying this, so we're just going to get really a tiny little taste of it. But anytime you read, like I said, a medical study or some kind of social work study or even a political poll, the person who's doing the study has performed some kind of inference. So you want to at least be informed about what kinds of inference are valid and what kinds are not. Okay, now here is an example for us to look at. And when you think example in math class, you're thinking about usually a problem to work that is like another problem you're going to be asked to work later. And really, that's not so much what we're doing here. But I just want to look at this example with you and see if we can kind of think through the process of statistics together. So I'm going to read it to you. It says, many studies evaluate batterer treatment programs, but there are few experiments designed to compare batterer treatment programs to non-therapeutic treatments such as community service. Researchers designed an experiment in which 376 male criminal court defendants who were accused of assaulting their intimate female partners were randomly assigned into either a treatment group or a control group. The subjects in the treatment group entered a 40-hour batterer treatment program, while the subjects in the control group received 40 hours of community service. After 6 months, it was reported that 21% of the males in the control group had further battering incidents, while 10% of the males in the treatment group had further battering incidents. The researchers concluded that the treatment was effective in reducing repeat battering offenses. Now let's take the experiment that we just read about and compare that to our 4-step process of statistics that we learned about a few minutes ago. Step 1 in the process of statistics is to identify the research objective. Well, what were they trying to find out in this experiment? They were trying to find out if their batterer treatment program was effective or not. So we could say that the research objective is to determine whether males accused of battering their intimate female partners that were assigned into a 40-hour batterer treatment program are less likely to batter again compared to those assigned to 40 hours of community service. Okay? After we identify the research objective, then we want to collect the information needed to answer the question. So how did they collect information? They randomly divided the subjects into 2 groups, and Group 1 then participated in the 40-hour batterer program, while Group 2 participants received 40 hours of community service, and 6 months after the program ended, they went back to determine what percent had repeated the offense. Okay, step 3 would be to describe the data, organize and summarize the information. So remember when they calculated the percents for each group? That was organizing and summarizing the data. The demographic characteristics of the subjects in the experimental and control group were similar. After the 6-month treatment, 21% of the males in the control group had further battering incidents, while 10% of the males in the treatment group had any further battering incidents. So really right here is the summarizing of the information. And then step 4 would be to draw conclusions from the data. And we saw that the researchers concluded that the batterer treatment program was effective. Now, I would not expect you to be able to read any experiment summary and come up with all of these words, but I just want you to keep in mind the 4-step process as we go through the course. Keep in mind it's always identify the question, collect the data, describe the data, and draw a conclusion. And so that's always what we're looking at.